Hi guys, welcome to today's lecture. Today we introduce another inferential analysis technique, namely hypothesis testing. Hypothesis testing is a key inferential analysis tool. In hypothesis testing, we try to test a given or a stated hypothesis or assumption regarding unknown population parameter using data from a selected sample. In other words, we use sample data in order to test whether a given assumption regarding unknown population parameter is true. In hypothesis testing, we are dealing with the following terminologies. First, null hypothesis states the status quo, in other words, the assumption on the existing condition. H1 is the alternative hypothesis, is the opposite of H null. In hypothesis testing, we try to use the sample data in order to reject or not to reject the null hypothesis. In doing so, we may make one of the following errors or mistakes. First, we may reject a null hypothesis, which is true. In other words, based on our sample data, we may reject a null hypothesis, which is true in the population. Here you see we are making a mistake. In statistics, we call this mistake as a type 1 error. Second, we may fail to reject a false null hypothesis. In other words, based on our sample data, we may fail to reject a null hypothesis, which is not true in the population. Again, here we are making a mistake. In statistics, we refer to this mistake as type 2 error. Using probability theory, we can quantify the probability of type 1 error and type 2 error. The probability of making type 1 error is called p-value. In other words, probability of type 1 error is equal to the p-value. I hope it's now clear for you that why in the past lectures we were emphasizing that the smaller is the p-value, the better it is. Because the smaller is the p-value, the smaller is the probability of making type 1 error. In other words, the smaller is the p-value, the smaller is the chance or the probability of us making a mistake. Using the probability of type 2 error, we can define and quantify the power of the test. The power of the test is equal to 1 minus the probability of type 2 error. Now you see from this equation, the smaller is the probability of type 2 error, the higher is the power of the test. In hypothesis testing, we need the following steps. First, we need to write down H0 and H1 regarding an unknown population parameter. Then we need to specify the p-value. Normally it is about 5% or less. Then compute the corresponding t-statistic and then compute the corresponding p-value, and then based on that p-value decide whether to reject or not to reject the hypothesis. And the last step, we need to interpret our result. In our course, we divide the hypothesis testing into one sample univariate and two sample bivariate hypothesis testing.